So, in this video, I'm going to be going over the basics of chemical equations. I went over balancing them in a previous video. You can check that out. That's more math. I'm going to be going over the conceptual of it. So in this reaction, this is how water is synthesized. We see that 2 moles of hydrogen gas, or 2 moles of hydrogen, react with oxygen to form water. So, in chemistry, we say that these are the reactants, or I guess in all forms of science, we say these are the reactants, and these are the products. So, another thing that's important to realize is that there are 3 moles of reactants, 2 moles of hydrogen gas, and 1 mole of oxygen, and there are only 2 moles of products, so 2 moles of water. This means that this reaction will most likely occur in situations where you want less moles of stuff. If you have a more condensed area, you need a smaller condensed space. This kind of reaction will be preferred. This will be useful in realizing Le Chatelier's, which we'll go over in a while. And another important thing to realize, super important, is that you need to write down the reaction states of your reactions and products in your chemical equations. This is just to clarify the physical state of it, and it also kind of clarifies the conditions that you need for this reaction. So, just as an example, hydrogen is going to be a gas, and oxygen is going to be a gas, and water is going to be a gas. So you just write it like a subscript under it, just saying what it is as the single letter. So, for example, gas is just G. Solid is S. If it's in a solution, so it's like if you have something in water, dissolved in water, you're writing AQ for aqueous. And if it's just a liquid version of itself, like if you have liquid hydrochloric acid, you're just going to write a cursive L. Don't ask me why. So yeah. What? Where the fuck is he? Another thing that's important to understand is that the states of your reactions and products are extremely necessary. You need to include that in all of your reactions, especially in shorthand and in writing your formal lab reports and your AP exam FRQs, stuff like that. This is so that you can clarify what's going on in your reaction. The physical state is super important. So you include the state of the reactants and products just by making a little parentheses under the compound or element, just saying what it is. So this is a gas. Oxygen is a gas. Oh, sorry, this is 2 oxygens. Whoops. Oxygen is also a gas. Carbon is a gas. Carbon dioxide is a gas. And water in this reaction is going to be a gas. So, yeah.
I really will. This is not an emotional play. Fuck you, bitch! What?
Okay, so types of reactions. So first we'll go over combination and decomposition reactions. So combination reactions, they follow an A plus B becomes C type of thing. It can also be A plus B plus C plus D becomes E, but that's generally what it is. So you can see that the first reaction I have here is a combination reaction where magnesium and oxygen gas form magnesium MgO, I forget the name. Magnesium oxide, yes, magnesium oxide. So that's a combination reaction. And then a decomposition reaction just follows the format but in reverse. So C becomes A plus B. We can see that in the second reaction, where perchlorate decomposes into KCl, and oxygen gas. And those are really important. You'll see that a lot in chemistry, so just remember those names and just remember like in this decomposition reaction, you know what that is. You know that one big thing is becoming two smaller things, or in this combination reaction, these two small things are going to become this one big thing. Now, generally, you'll see that decomposition reactions happen in higher or lower temperatures because things like KClO3, they're relatively unstable. So if they have too much energy or too little energy to stay together, they'll just break apart. And combinations is when things like unstable things form to become more stable things, or you force unstable things to come together to form something else. So yeah.
Bruh. Look at this dude. Wait till you see the. No, 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 no. Look at the top of his head. Look at his lips.
So the last major one is combustion reactions, and that's when a thing happens to produce a flame. So that's always when something happens with an oxygen and a reactant. So in this one specifically, this hydrocarbon is going to react with these oxygens in the air, presumably, to produce a large amount of energy, so a flame, to produce CO2 and water. Combustion reactions are common. That's what happens when you burn wood. That's what happens when you burn down a building. That's what happens when you do all that stuff. In trees, the glucose and the glucase of trees, they go through combustion reaction to explode. So yeah, that's all.